Look at your hand right now. No, seriously. Stop whatever you're doing and just look at it. The colour you're seeing, whether it's pale ivory, golden tan, rich brown, or deep ebony, is telling a story. A story about where your ancestors lived thousands of years ago, what challenges they faced, and how they adapted to survive in places that should have killed them. Here's something that might blow your mind. If you have light skin, pale skin, what we call white skin, you're looking at one of the most recent evolutionary developments in human history. We're not talking ancient, we're talking newer than agriculture, newer than cities, newer than pottery. In the grand timeline of humanity, white skin just showed up, like, recently. Every human alive today, all 8 billion of us, had ancestors in Africa around 200,000 years ago, and every single one of those ancestors had dark skin. Dark brown, melanin-rich skin designed for intense equatorial sunshine. That was the default, the original, the baseline for what human skin looked like. So what happened? How did some humans end up looking so radically different? Why do Swedish people look nothing like Nigerians when we're all the same species, all descended from the same African population? The answer isn't what you might think. It's not about different races evolving separately for millions of years. It's not about fundamental biological differences. It's about something way more fascinating. It's about desperate survival in hostile new environments, about the human body's incredible ability to adapt, and about changes so dramatic they rewrote our DNA in just a few thousand years. If you're using this to fall asleep, perfect. That's exactly why I make these. So maybe subscribe and tell me where you are and what time it is. I love checking the comments and seeing Tokyo at dawn, London at lunch, Los Angeles at lights out, all watching the same story unfold. This is a story about migration, about humans leaving the warm embrace of Africa and venturing into cold, dark places where the sun barely shone. Places that should have killed them, and in a very real sense those places were killing them, until their bodies changed, until mutations, random and accidental, gave some people an edge, a survival advantage so powerful that within a few thousand years, entire populations had transformed. The science behind skin colour turns out to be way more complex and fascinating than anyone realised until very recently. It's not just about one gene or one simple change, it's about multiple genetic mutations happening in different populations at different times, all solving the same problem in slightly different ways. It's about vitamin D and folate, about rickets and birth defects, about mothers trying to keep their babies alive through brutal northern winters. And here's what makes this story perfect for drifting off to sleep. It's not rushed. Evolution never is. We're going to travel slowly through 50,000 years of human history, following our ancestors as they spread across the globe, watching their skin gradually lighten in response to new sunlight conditions. We'll meet the specific people whose genetic mutations made pale skin possible. We'll discover why some populations became white while others didn't, even though they lived at similar latitudes. We'll uncover the surprising role that farming played in accelerating these changes. Most importantly, we'll understand what skin colour actually means and what it doesn't. Because here's the thing that modern genetics has proven beyond any doubt. The physical differences we can see between human populations, the things we've built entire systems of discrimination around, represent the tiniest fraction of our genetic code. We're talking about a handful of genes out of about 20,000. The vast majority of human genetic diversity exists within populations, not between them. But tonight we're not here for sociology or politics. We're here for the story. The actual, scientific, archaeological, genetic story of how humans became white. It's a detective story written in DNA, pieced together by scientists over decades of painstaking research, and it's way more interesting than any simplified version you might have heard before. So get comfortable, relax your shoulders, let your breathing slow down. We're about to travel back in time to when all humans were dark and follow the journey that led some of them to transform into something new. A journey of survival, adaptation, and the incredible flexibility of the human body. The mystery written in your skin is about to be revealed. Before anyone was white, before anyone was pale, before skin colour became something humans even thought about, we were all dark. Every single one of us. Your ancestors, my ancestors, everyone's ancestors. Around 300,000 years ago, in the sun-baked landscapes of Africa, modern humans emerged, and they all had one thing in common: dark brown skin, rich in melanin, perfectly adapted to the environment that created them. This wasn't random. Evolution doesn't do random when survival is on the line. Dark skin was the solution to a very specific problem, one that would kill you if you got it wrong: the African sun. Picture the world your earliest ancestors inhabited. Not the Africa of today, though parts of it remain similar, but the Africa of the Middle Pleistocene. Grasslands stretching to the horizon, broken by scattered acacia trees and rocky outcrops. The equatorial sun beating down with an intensity that's hard to comprehend if you've never experienced it. At noon, there's almost no shade. The sun is directly overhead, and UV radiation pours down like an invisible fire. This is where humans evolved, not in forests where thick canopies filter sunlight, not in temperate zones where clouds provide regular relief, but in the open savannas of equatorial Africa, where our ancestors had left the trees behind and were learning to walk upright across exposed grasslands. That upright posture changed everything. When our ape ancestors walked on all fours, most of their body surface was shaded by their own torso. The sun hit mainly their backs, and thick body hair provided additional protection. But when our ancestors stood up and lost most of their body hair, probably to improve cooling efficiency through sweating, they exposed massive amounts of skin directly to the sun. This created a crisis. UV radiation isn't just uncomfortable. It's destructive at the molecular level. It breaks chemical bonds. It damages DNA. Most critically for our ancestors, it destroys folate, a B vitamin absolutely essential for human survival. Folate does something remarkable. It protects DNA during cell division, especially during the rapid cell division that happens when embryos are forming. Without adequate folate, neural tubes don't close properly. Spines don't form correctly. Pregnancies fail. Even in adults, folate deficiency causes anemia, weakness, the inability to heal wounds properly. In the harsh environment of prehistoric Africa, folate deficiency was a death sentence. The African sun destroys folate. Studies show that just a few hours of intense UV exposure can degrade folate levels in the bloodstream by more than half. Now imagine you're an early human spending 12 hours a day outside, hunting, gathering, travelling between water sources. Without protection, your folate reserves would be depleted constantly. Enter melanin, nature's perfect sunscreen. Melanin is a pigment produced by specialised cells called melanocytes in the deepest layer of your skin. It comes in different forms, but the most important for UV protection is eumelanin, the brown-black pigment that gives skin its darker tones. Eumelanin acts like billions of tiny umbrellas scattered throughout your skin, absorbing and dissipating UV radiation before it can penetrate to the deeper layers where blood vessels and DNA-rich cells reside. The more melanin you have, the more protection. Dark brown skin can absorb and neutralize UV radiation dozens of times more effectively than pale skin. It's not perfect, nothing in evolution is, but it's remarkably effective. Effective enough that early humans with darker skin could spend entire days under the African sun without suffering folate depletion. This wasn't just advantageous, it was mandatory. In the environment where humans evolved, dark skin was the difference between successful reproduction and genetic extinction. Women with insufficient melanin would have higher rates of pregnancy failure and birth defects. Children with pale skin would have been more susceptible to sunburn, skin damage, and the long-term effects of UV exposure. Adults would have suffered folate deficiency and its cascade of health problems. Natural selection doesn't mess around with problems this fundamental. Any genetic variation that increased melanin production would spread through the population rapidly. Within just a few thousand generations, basically nothing in evolutionary time, all humans living in equatorial Africa would have had dark skin. And they all did. Every single anatomically modern human who lived in Africa before the Great Migrations had dark brown skin. The genetic evidence is unambiguous. The variations in genes that control melanin production, the mutations that would later create lighter skin, none of them existed yet. Or if they did exist as random mutations, they were selected against, eliminated because they reduced fitness in the African environment. Think about what this means. For the first 240,000 years of modern human existence, maybe longer, skin color wasn't variable. It wasn't a marker of different populations or different groups. Every human who looked at another human saw someone whose skin was roughly the same shade as their own. Dark skin wasn't a trait that needed explaining. It was just what humans looked like. Life in those early African populations was hard but manageable. Your ancestors weren't struggling against their environment, they were adapted to it. They could hunt during the heat of the day without suffering sun damage. They could gather plant foods in exposed areas without worrying about UV radiation destroying essential nutrients in their bodies. Women could carry pregnancy successfully, producing healthy children with properly formed nervous systems. The archaeological evidence from this period shows humans thriving. Not just surviving, but developing increasingly sophisticated technologies and social structures. They were making specialized tools, hunting large game, gathering diverse plant resources. They were creating art, at least by 100,000 years ago, and probably earlier. They were developing the complex social networks that would eventually allow them to spread across the entire planet. And through all of this, through all these advances in technology and culture, their skin remained consistently dark. Because in Africa, under that intense equatorial sun, dark skin was simply what worked. But skin color does more than just protect folate. It's a balancing act, a compromise between competing needs. Because while UV radiation is dangerous, it's also essential. Humans need sunlight to produce vitamin D, a crucial nutrient for bone development, immune function, and dozens of other physiological processes. UV radiation hitting skin triggers a chemical reaction that synthesizes vitamin D. In equatorial Africa, this was never a problem. The sun is so intense that even heavily pigmented skin produces adequate vitamin D. Your dark-skinned ancestors got all the vitamin D they needed despite the UV-blocking properties of their melanin. The sun was strong enough to penetrate even nature's best sunscreen. This is the key point. In the environment where humans evolved, dark skin represented the optimal balance. Maximum protection from UV damage, but still enough UV penetration to maintain vitamin D production. It was the Goldilocks solution. Not too much UV getting through, not too little. Just right. Your earliest ancestors didn't think about any of this, of course. They didn't know about melanin or folate or vitamin D. They just lived under the African sun, generation after generation, shaped by forces they couldn't see or understand. But those forces were real, and they were powerful. They wrote the first chapter of human skin color in dark brown pigment. Then, around 60,000 years ago, some of those dark-skinned Africans did something unprecedented. They left. Small groups, probably just a few hundred individuals at first, crossed from Africa into the Arabian Peninsula and beyond. They carried with them all the genetic and cultural adaptations that had made them successful in Africa, including their dark skin. They didn't know it yet, but they were carrying an adaptation that was perfect for Africa and increasingly problematic for everywhere else they were about to go. The story of how human skin colour diversified, how some populations became pale while others remained dark, starts with this migration. With dark-skinned people walking into environments where darkness itself would become a liability. But we're getting ahead of ourselves. For now, rest in this knowledge that the deepest, oldest human adaptation, the one we all carried for hundreds of thousands of years, was dark skin. Rich, melanin-filled, sun-adapted, dark brown skin. Before we were anything else, before we were diverse, before we were scattered across the world, we were all dark, all children of the African sun, all carrying the same protective pigment our ancestors needed to survive in the place where humanity was born. That darkness isn't a variation or a deviation, it's the original human condition, the baseline from which everything else emerged, and in its own way, that's beautiful. We all start from the same place, painted in the same shades, protected by the same molecular shields our earliest ancestors evolved beneath the oldest human skies. So your ancestors survived the bottleneck. They made it through 117,000 years of near extinction. Their populations exploded, spreading across Africa, developing new technologies and complex social systems. For hundreds of thousands of years, they thrived in the continent where humanity was born. Then, around 70,000 to 100,000 years ago, something remarkable happened. A small group decided to leave. Not all humans, not even most humans, just a few hundred individuals who walked away from everything their ancestors had known and ventured into completely unknown territory. Why would anyone do this? Why leave Africa, where humans had lived successfully for millions of years, where the climate was familiar, where people knew which plants were edible and which animals were dangerous? The honest answer is we don't know for certain, but we can make some educated guesses based on what we know about human behaviour and the environmental conditions at the time. First, the climate was changing again. Not catastrophically like during the bottleneck, but enough to matter. Africa was experiencing cycles of expansion and contraction in habitable zones. During wet periods, the Sahara would green up, becoming a grassland paradise full of lakes and rivers. During dry periods, it would contract back into the desert we know today. These cycles created a kind of pump effect. When conditions were good, populations would expand northward. When conditions deteriorated, they'd contract back south. But not always completely. Some groups would get stranded in refuges along the edges. Some would find ways to keep moving forward rather than retreating. And some would discover that the lands beyond Africa, while different, were also habitable. Second, human populations were growing. By 70,000 years ago, Africa probably held hundreds of thousands of people, maybe more. That might not sound like much compared to today's billions, but for hunter-gatherers who needed large territories to support each group, it was getting crowded. Competition for the best hunting grounds and gathering areas was intensifying. Young groups, especially young men looking to establish their own territories and families, would have felt the pressure. Moving into unexplored lands might have seemed less risky than fighting for increasingly contested resources at home. Third, humans had become really good at adapting to new environments. The descendants of the bottleneck survivors had been refining their survival skills for hundreds of thousands of years. They knew how to read landscapes, identify new food sources, develop new hunting strategies. The unknown wasn't as frightening to them as it might have been to their ancestors. They had the tools, both physical and mental, to take on the challenge. And fourth, there's something in human nature that just wants to see what's over the next hill. Call it curiosity, call it restlessness, call it the explorer's instinct. Whatever you call it, it's a fundamental part of what makes us human. Some individuals in every generation feel that pull to move, to discover, to push boundaries. When those individuals started walking north out of Africa, they changed the course of human history forever. The initial migration probably wasn't dramatic. No one woke up one morning and decided to leave Africa permanently. It was gradual, generation by generation, groups moving a little further north, establishing seasonal camps that became permanent settlements, discovering new territories and deciding to stay. The first exit route was probably through the Middle East. During favourable climate periods, the Arabian Peninsula wasn't the harsh desert it is today. It was grassland dotted with lakes and crossed by rivers. Archaeological sites from this period show that humans were following these water sources, tracking the herds of large mammals that grazed along the fertile corridors. Some groups travelled along the coast, following the shoreline of the Red Sea and then around the Arabian Peninsula. This coastal route had enormous advantages. Seafood provided reliable protein even when land animals were scarce. Coastal environments were less subject to the extreme seasonal variations that made inland areas challenging, and the coast itself served as a natural navigation tool. Just keep the water on your left and keep walking. You can't get lost. These coastal migrants became specialists in a new kind of resource exploitation. They learned to read tides, to identify edible shellfish, to catch fish in shallow waters. Archaeological sites along ancient coastlines, now submerged by rising sea levels, show evidence of sophisticated seafood processing. These weren't desperate refugees surviving on whatever they could find. These were skilled specialists developing new technologies and new cuisines. They were innovating, adapting, thriving in environments their ancestors had never known. Other groups moved inland, following river valleys into the heart of Asia. The route along the Persian Gulf, up the Tigris and Euphrates rivers into Mesopotamia and beyond, became a major highway for human migration. These river valleys were oases of fertility and otherwise challenging landscapes. They provided water, game, edible plants, and natural pathways through mountains and deserts that would have been impassable otherwise. But here's where things get interesting. These migrants were walking into a world that already had people in it. Remember those Neanderthals and Denisovans we talked about? The descendants of the post-bottleneck populations that had left Africa hundreds of thousands of years earlier? They were still around, still thriving in Europe and Asia, and they weren't necessarily happy about new arrivals moving into their territories. The archaeological record shows that modern humans and Neanderthals coexisted in the Middle East for thousands of years. Not necessarily peacefully, not necessarily as enemies, but definitely interacting. We know they interbred because modern humans of European and Asian descent carry Neanderthal DNA. Those genetic encounters probably represented everything from violent conflict to peaceful trade relationships, to romance and marriage between groups. The Denisovans were out there too, spread across Asia from Siberia to Southeast Asia. Modern humans encountered them in multiple locations over thousands of years. Like the Neanderthals, Denisovans also interbred with modern humans. Their genetic legacy survives in modern Asian, Australian and Pacific Island populations. Some of those inherited genes turned out to be incredibly valuable, providing adaptations to high altitude, resistance to certain diseases and other survival advantages that are still helping people today. As modern humans continued spreading, they encountered an astonishing variety of environments. Groups moving north into Central Asia faced vast grasslands called steppes, endless rolling plains where survival depended on following migrating herds of horses, bison, and mammoths. The climate was harsh, with brutal winters and brief intense summers, but the hunting was spectacular if you had the skills to exploit it. Other groups moved east into what is now China and Southeast Asia. These regions offered a completely different set of challenges and opportunities. Dense forests full of unfamiliar plants and animals, river systems prone to flooding, tropical diseases that had never existed in Africa, monsoon climates with extreme wet and dry seasons. The groups that succeeded in these environments had to develop entirely new survival strategies. Still others moved north into Europe, entering territories that were dominated by Neanderthals who had been there for hundreds of thousands of years. These encounters seem to have been particularly significant. The archaeological record shows that modern humans and Neanderthals lived in close proximity in places like the Middle East and southern Europe for thousands of years. They used similar tools, hunted similar prey, even seemed to share some cultural practices. But something about modern humans gave them an edge. Maybe it was slightly better communication abilities. Maybe it was more flexible social structures that allowed larger groups to cooperate. Maybe it was just luck, being in the right places when climate conditions shifted. Whatever the reason, modern humans gradually expanded while Neanderthals contracted. By about 40,000 years ago, Neanderthals had vanished from most of their former range, holding out in a few refuges in Spain and the Balkans before disappearing completely around 30,000 years ago. The pace of migration was breathtaking in evolutionary terms, but glacially slow in human terms. It took thousands of years for modern humans to spread from Africa to Australia, thousands more to reach Europe completely, many more thousands to cross into the Americas. Individual people didn't travel these entire distances. It was a multi-generational relay race, with each generation moving a little further into new territories, establishing new settlements that became jumping-off points for the next wave of explorers. And with each new environment, natural selection was at work. The humans who left Africa carried with them the same dark skin that had protected their ancestors from intense tropical sunlight for millions of years. That skin colour was perfect for Africa. It was about to become a serious problem, because the further north these migrants travelled, the less sunlight they received, and the less sunlight they received, the harder it became for their dark skin to produce enough vitamin D. This was setting up a biological crisis that would fundamentally change what humans looked like. But before we get to that crisis and how humans solved it, take a moment to imagine what these first migrants experienced. Leaving behind everything familiar, walking into landscapes no human had ever seen, encountering animals that had never learned to fear people, tasting plants that no human tongue had ever touched, finding rivers that no one had named, mountains that no one had climbed. Every day brought something new. Every season presented different challenges. These weren't just survivors, these were pioneers, pushing humanity into every corner of the inhabitable world. And they were still changing, still evolving, still adapting to whatever challenges their new homes presented. The stage was set for one of the most dramatic transformations in human history. The loss of the very thing that had defined humans since the beginning, their dark skin. So your ancestors made it north, out of Africa, across the Middle East, and eventually into Europe and Central Asia. They were carrying the same dark skin that had protected their African ancestors for millions of years. Beautiful melanin-rich skin perfectly adapted for life under the African sun. And that skin was about to become a death sentence. Here's the thing nobody tells you about human migration. It's not just about finding new territory and figuring out how to hunt different animals. It's about your body suddenly being in an environment it was never designed for. And for dark-skinned humans moving into northern latitudes, the most critical challenge wasn't the cold, wasn't the different food sources, wasn't even the Ice Age megafauna. It was something much more invisible, much more insidious. It was sunlight, or rather, the lack of it. Let's talk about vitamin D, And before your eyes glaze over because this sounds like a supplement commercial, understand this. Vitamin D isn't really a vitamin at all. It's a hormone, a crucial hormone that your body manufactures when ultraviolet B rays from the sun hit your skin. Without it, you don't just feel a little tired or get sick more often. Without it, your body fundamentally stops working properly. Vitamin D regulates calcium absorption. Without adequate vitamin D, your body can't pull calcium from your food into your bloodstream. And without calcium, your bones don't mineralize properly. They stay soft, weak, prone to deformity and fracture. In children, this causes a disease called rickets, legs that bow outward under the weight of the growing body, ribs that develop abnormal bumps and depressions, skulls that soften and deform, spines that curve and compress. In adults, the condition is called osteomalacia. Your existing bones start losing their mineral content, becoming progressively weaker even without any obvious injury. Fractures happen from normal activities, bones ache constantly, muscles weaken because calcium is also essential for muscle contraction, but it gets worse, much worse. Vitamin D is critical for immune function. Without it, your body's ability to fight infections plummets. People with severe deficiency get sick constantly, and they don't recover properly. Wounds don't heal. Respiratory infections that would be minor annoyances become life-threatening illnesses. In the dangerous, disease-ridden environments of prehistoric Europe and Asia, this alone would have been devastating. The hormone also regulates cell growth and helps prevent runaway cellular proliferation. People with chronic vitamin D deficiency show increased rates of various cancers. Their cardiovascular systems don't function optimally. Their brains don't produce neurotransmitters efficiently, leading to depression, cognitive impairment, and developmental delays in children. But the absolute worst effect, the one that made vitamin D deficiency a direct evolutionary crisis, was what it did to women's ability to give birth. Picture this. You're a young woman living in what is now Germany, maybe 40,000 years ago. You've survived childhood, which was no small feat. You've learned to hunt and gather in this cold, seasonal environment. You've found a mate, and now you're pregnant with your first child. You should be optimistic. Your group has food stored for winter. The cave you're sheltering in is secure. Everything seems set up for success. But you grew up with insufficient sunlight exposure. Your dark skin, perfect for Africa, blocked most of the weak UV rays that made it through the clouds and reached you during the short northern summers. Year after year, your body struggled to produce enough vitamin D. Year after year, your bones didn't mineralize quite right. The effects were subtle at first. Maybe you were a bit shorter than you should have been. Maybe you got sick more often. Maybe you felt tired a lot. But you survived. You adapted. You thought you were fine. Then you go into labour, and your pelvis, which developed without adequate vitamin D during your childhood and adolescence, isn't shaped right. Rickets had deformed it just enough. The birth canal is too narrow, the bones positioned at slightly wrong angles. The baby can't pass through. In the modern world, this means a C-section. In prehistoric Europe, this meant death. Both mother and child, gone. All because of sunlight and melanin and a mismatch between the two. This wasn't rare. This wasn't an occasional tragedy. Archaeological evidence from early northern populations shows high rates of pelvic deformities consistent with childhood rickets. Skeletal remains show the telltale signs: bowed legs, deformed ribs, bone abnormalities that would have made childbirth extraordinarily dangerous. Here's what makes this absolutely brutal. The women who died this way were the healthy ones. They were the ones who survived childhood, who made it to reproductive age, who found mates and successfully conceived. They did everything right. And then their skeleton, shaped by years of vitamin D deficiency, kill them during the most fundamental biological process of all. The math was devastating. If even a fraction of women in each generation died this way, and if the survivors had fewer children because of poor health, weakened immune systems and repeated infections, the population couldn't sustain itself. Groups would shrink, genetic diversity would decline. Within a few thousand years, dark-skinned humans in northern latitudes would simply go extinct. And yet, obviously they didn't go extinct. You're alive, possibly reading this with pale or light brown skin that tells the story of how your ancestors solved this crisis. But we're getting ahead of ourselves. First, understand just how severe the vitamin D problem was in northern latitudes. In equatorial Africa, the sun is directly overhead year-round. UV radiation is intense and constant. Even very dark skin, loaded with melanin that blocks most UV rays, still allows enough penetration to produce adequate vitamin D. Your African ancestors could make all the vitamin D they needed with just a few minutes of sun exposure per day. Move to Northern Europe, and the physics changes completely. The sun never gets directly overhead. Its rays travel through much more atmosphere before reaching the ground, filtering out most of the UVB radiation needed for vitamin D synthesis. During winter, which can last 6 months or more at high latitudes, the sun angle is so low that virtually no vitamin D production occurs regardless of skin color. Even in summer, the sun is weak and often hidden behind clouds for days or weeks at a time. Do the calculation. Dark skin evolved to block about 90% of UV radiation. This is perfect in Africa, where UV levels are high enough that the remaining 10% is still plenty for vitamin D production. Move to Northern Europe, where UV levels might be only 10% of what they are in Africa. And now your dark skin is letting through maybe 1% of the original African level. It's not enough. Not even close. Archaeological evidence shows this crisis playing out in real time. Early modern human remains from northern regions show widespread vitamin D deficiency markers. Bone analyses reveal the chemical signatures of inadequate mineralization. Skeletal deformities consistent with childhood rickets appear in the fossil record as humans spread north. Genetic evidence tells the same story. When scientists analyze ancient DNA from the earliest Europeans, they find something remarkable. Those people, the ones who first settled Europe between 40,000 and 10,000 years ago, they still had the genes for dark skin. They hadn't yet evolved the mutations for lighter pigmentation that would eventually dominate European populations. They were trying to survive with African skin in European conditions, and they were paying a terrible price. Some groups probably tried behavioral adaptations. Maybe they spent more time outdoors despite the cold, maximizing whatever sun exposure they could get. Maybe they removed more clothing during summer, exposing as much skin as possible to the weak sunshine. Maybe they preferentially settled in areas with more reliable sunny weather. But behavior can only compensate so much. You can't will your body to produce vitamin D from insufficient UV radiation. You can't think your way into stronger bones or a properly shaped pelvis. The laws of biochemistry and physics don't care about cultural adaptations. This was a crisis that required a biological solution. The human body needed to change, needed to become more efficient at capturing the scarce UV radiation available at northern latitudes. Natural selection needed to favor individuals whose skin was just a little bit lighter, just a little bit more transparent to UV rays. And that selection pressure needed to be powerful enough to overcome the massive disadvantage of a lighter skin in high UV environments, strong enough to spread new mutations through the population within just a few thousand years. It needed to be quite literally a matter of life and death, and it was. Women with slightly lighter skin could produce more vitamin D. Their bones developed more normally. Their pelvises formed properly. They could survive childbirth and raise children, while their darker-skinned counterparts died in labour or struggled with chronic illness and repeated miscarriages. The selection pressure was enormous, probably stronger than almost any other force acting on human populations at the time. And when natural selection pushes that hard, evolution responds fast. The stage was set for one of the most rapid evolutionary transformations in human history. Now here's where the story gets molecular, where evolutionary pressure meets random chance and changes the appearance of entire populations forever. Your ancestors are living in Northern Europe and Northern Asia. They've been there for thousands of years, struggling with the vitamin D crisis, losing children to rickets and birth complications. Natural selection is screaming for a solution. But evolution doesn't plan. It doesn't design. It just waits for random mutations and then decides which ones get to survive. And then, in some individual whose name we'll never know, in some group whose location we can only guess at, a copying error happened. Deep in the genetic code, in a gene called SLC24A5, a single letter changed. One nucleotide out of 3 billion, the molecular equivalent of a typo in an encyclopedia. This gene codes for a protein involved in melanin production, the pigment that makes skin dark, and this one tiny change, this single-letter substitution, reduced melanin production by about 30 to 40%. The person born with this mutation would have been noticeably lighter than their parents, not white like modern Northern Europeans, but distinctly paler. Different enough to be remarkable in a population where everyone else was dark brown or black. In most places, at most times in human history, this mutation would have meant nothing. Maybe a slight disadvantage, actually, since lighter skin is more vulnerable to sun damage. The individual might have passed it on to a few descendants, and then it would have disappeared, diluted back into the gene pool. But remember where we are. Northern latitudes, low UV radiation, populations suffering from chronic vitamin D deficiency. And here comes an individual whose lighter skin allows their body to synthesize vitamin D more efficiently than anyone around them. They were healthier. Their bones were stronger. If they were female, they had easier pregnancies and healthier babies. If they were male, they were more vigorous, more likely to survive winters, more attractive to potential mates. They had more children. And crucially, those children inherited the mutation and had the same advantages. Within a few dozen generations, maybe 1,000 years, this single mutation had spread through the entire population. Not because anyone decided lighter skin was better, not because of culture or preference or conscious choice, simply because individuals carrying this mutation were slightly more likely to survive and reproduce than those who didn't. This is natural selection at its purest, a random genetic change meeting an environmental pressure and spreading through a population because it solves a survival problem. But SLC24A5 wasn't working alone. It was just the beginning. Around the same time, or maybe a few thousand years later, other mutations were popping up in other genes. SLC45A2, another gene involved in melanin production, underwent its own random change. This mutation further reduced pigmentation, particularly affecting skin and hair colour. Individuals carrying both the SLC24A5 and SLC45A2 mutations were even lighter than those with just one. Then came changes to TRP1, a gene that affects the type of melanin produced, and OCA2, which not only influences skin colour, but also eye colour, which is why these traits often change together in populations. Each mutation by itself had a relatively small effect, but together they were transformative. A person carrying mutations in all 4 of these genes could be dramatically lighter than their ancestors just a few thousand years earlier. And here's what's really wild. These mutations didn't all happen in the same place or at the same time. The genetic archaeology shows us that different populations developed lighter skin through different genetic pathways. The mutation in SLC24A5 that's common in Europeans is almost completely absent in East Asian populations, but East Asians also have light skin. They got there through different mutations in different genes, particularly in OCA2 and other pigmentation genes we're still identifying. This is convergent evolution. Two separate populations facing similar environmental pressures, evolving similar solutions through completely different genetic changes. It's like two engineers solving the same problem with different tools. The result looks similar, but the mechanism is entirely different. This tells us something profound. The shift to lighter skin in northern populations happened independently, multiple times, in multiple places. It wasn't a single event that spread around the world. It was a universal response to the same environmental pressure, evolution finding the same solution again and again because it worked. Now, let's talk about timescales, because this is where the story gets really interesting. These mutations are recent, shockingly recent in evolutionary terms. The SLC24A5 mutation, that's nearly universal in modern Europeans, shows signs of positive selection, starting only about 10,000 to 20,000 years ago. Some estimates put it even more recently, perhaps as little as 6,000 to 8,000 years ago. Think about what this means. 20,000 years ago, even the populations living in northern Europe probably still had relatively dark skin. Not as dark as equatorial Africans, maybe, but much darker than modern Europeans. The pale skin we associate with northern Europeans today is a very recent innovation, newer than pottery, newer than agriculture in many regions, newer than most of the major human migrations. We have physical evidence supporting this timeline. The oldest intact European genome we've sequenced, from a man who lived in Spain about 7,000 years ago, shows he had dark skin and blue eyes. A combination that seems strange to us today but was probably common in ancient Europe. He carried the genes for blue eyes, which had evolved earlier, but not yet the mutations for pale skin. This means skin colour changed faster than almost any other human trait we can measure. Within just a few hundred generations, populations went from dark brown to pale. That's evolutionary lightning speed. Why so fast? Because the selection pressure was intense. In northern latitudes with limited sunlight, the vitamin D crisis wasn't just making life uncomfortable. It was killing people, specifically killing pregnant women and young children at rates high enough to create massive evolutionary pressure. Any mutation that improved vitamin D synthesis, even slightly, provided enormous survival advantages. Individuals carrying these mutations might have had 10, 20, maybe 30% higher reproductive success than those without them. Over just 100 generations, that kind of selection pressure can completely transform a population's appearance. But here's what really matters, what you need to understand as you drift off to sleep tonight. These changes involved a tiny number of genes. Current research suggests that the vast majority of skin colour variation in modern humans is controlled by somewhere between 15 and 30 genes. Probably fewer than 20 account for most of the visible differences, out of approximately 20,000 genes in the human genome. Maybe 20 control skin colour, that's 0.1%. 0.1% of your genetic code determines whether you have dark skin or light skin. Put another way, a person with very dark skin and a person with very pale skin are genetically identical at 99.9% of their genes. The visible difference that seems so significant, that has caused so much social division and conflict throughout history, is the result of tiny tweaks to a microscopic fraction of the human genome. These are superficial adaptations, literally superficial, affecting only the surface of the body. They're no different in principle from the genes that determine whether you have attached or detached earlobes, whether you can roll your tongue, whether you have wet or dry earwax. just minor variations in a species that is fundamentally, genetically, almost completely identical across all populations. The mutations that changed skin colour didn't affect intelligence, personality, or capability. They couldn't have. Those traits are controlled by thousands of genes working in complex networks. You can't change them with a handful of mutations affecting pigment production in skin cells. What changed was melanin production. Nothing more. A simple biochemical adjustment to a single physiological system made necessary by changes in UV radiation exposure. An evolutionary adaptation as straightforward and uncomplicated as developing darker fur in forest animals or lighter feathers in Arctic birds. But unlike those animals, humans built entire social hierarchies around these superficial variations. We created categories, invented meanings, constructed elaborate mythologies to explain differences that were actually just simple adaptations to sunlight levels. We turned a minor biochemical adjustment into something we imagined was profound and fundamental. The genetics tells a different story. It says these changes were recent, superficial, and evolved independently in multiple populations through different mutations. It says skin colour is one of the least important ways that humans vary. It says we've been fighting for thousands of years over something that matters, genetically speaking, about as much as eye colour or hair texture. As those mutations spread through northern populations, they were simply solving a problem, making it possible for humans to survive and thrive in low-light environments where their ancestors' darker skin had become a liability. Nothing more, nothing less. But the story wasn't quite finished, because something else was about to happen that would accelerate these changes even faster, spreading pale skin across northern populations in just a few thousand years. Something that would transform human society and, unexpectedly, human appearance along with it. The agricultural revolution was coming, and it was about to change everything, including the colour of human skin. But then everything changed again. And this time, it wasn't climate. It wasn't migration. It was something humans did to themselves, completely by accident. Around 10,000 years ago, in a handful of locations scattered across the globe, people made a decision that would transform our species forever. They stopped hunting and gathering. They started farming. Now, this sounds like progress, right? The agricultural revolution, civilization, cities, writing. Everything we associate with human advancement came from this moment. And it's true, agriculture allowed human populations to explode. It created food surpluses that supported specialists, artisans, priests, warriors, eventually scientists and philosophers. It was the foundation of everything we call civilization. But in the short term, for the people who actually lived through the transition, farming was a disaster. Archaeological evidence shows that the first agricultural populations were shorter, sicker, and died younger than their hunter-gatherer ancestors. Their bones show signs of malnutrition. Their teeth reveal vitamin deficiencies. They suffered from diseases that had been rare or non-existent in hunter-gatherer societies. Why? Because early agriculture was basically a nutritional catastrophe. Hunter-gatherers ate incredibly diverse diets. Depending on the season and location, they might consume dozens of different plant species, multiple types of game, fish, shellfish, insects, eggs, honey. This diversity meant they naturally obtained a wide range of nutrients. They were constantly moving, constantly encountering new food sources, constantly maintaining balanced nutrition without even trying. Most importantly for our story, hunter-gatherers in northern latitudes had reliable sources of vitamin D in their diets. Fish, especially fatty fish like salmon and mackerel, are packed with vitamin D. So are fish eggs and fish liver. Seal meat and seal oil, Staples for Arctic populations contain massive amounts of vitamin D. Land animal livers, particularly from game like elk and reindeer, provide substantial amounts too. Even bird eggs contain decent quantities. Hunter-gatherers in places like Scandinavia could survive with relatively dark skin because they were eating vitamin D. Yes, they'd have seasonal deficiencies during the long dark winters. Yes, lighter skin would have helped. But they weren't in crisis. They could get by. Their children might not have optimal bone development, but they'd survive. Then came farming. And suddenly this dietary safety net vanished. The first agricultural populations didn't farm everything. They couldn't. Agriculture emerged independently in different regions, and in each place people domesticated whatever plants grew best in their local environment. In the Middle East it was wheat and barley, in China rice and millet, in Mesoamerica corn and beans, in Africa sorghum and yams. But here's what's crucial. None of these staple crops contain meaningful amounts of vitamin D. Plants don't make vitamin D, only animals do, and even then, only certain tissues. When you base your entire diet on cultivated grains and vegetables, you're essentially cutting yourself off from dietary vitamin D entirely. The early farmers of the Middle East weren't too badly affected because they were still living in relatively sunny regions. But when agriculture spread north into Europe, carried by migrating farming populations, the vitamin D crisis became acute. Imagine this. You're living in what's now Germany or Poland. It's 8,000 years ago. Your ancestors just arrived from the south, bringing domesticated wheat and barley. For the first time in human history, you can stay in one place year-round. You clear forests, plant fields, build permanent settlements. But your diet has gone from varied, with fish, game, wild plants, and seasonal diversity, to monotonous. Bread, porridge, maybe some vegetables if you're lucky, a bit of meat on special occasions, but nothing like the amounts hunter-gatherers consumed, and crucially, almost no fish. Agricultural populations settled inland, away from coasts and rivers, because that's where the best farming land was. Within a generation or two, the children are suffering. Rickets becomes epidemic. You're watching kids grow up with bent legs, deformed spines, weakened bones that fracture easily. Mothers are dying in childbirth because their pelvises never developed properly. Infants are dying from seizures caused by calcium deficiency. And remember, you're living at 50 degrees north latitude. In winter, the sun barely gets above the horizon. Even when it's out, it's too weak to trigger vitamin D synthesis in dark skin. You might get adequate sun exposure for 3 or 4 months per year. That's it. Under these conditions, the selective pressure for lighter skin didn't just increase, it exploded. This wasn't gradual anymore. This was a crisis happening in real time. Women with slightly lighter skin could synthesize vitamin D more efficiently. Their children had stronger bones. Their daughters survived childbirth more often. Their grandchildren were more numerous. The genetic evidence shows exactly what you'd expect from this kind of intense natural selection. The genes associated with light skin in Europeans, particularly the variants in SLC24A5 and SLC45A2, show what geneticists call signatures of recent positive selection. These genes that swept through European populations incredibly quickly, far faster than random genetic drift would predict. We can actually calculate how fast. Based on the prevalence of these variants in modern populations and the rate of genetic change, researchers estimate that light skin genes went from rare to nearly universal in European farming populations in just 3,000 to 5,000 years. That's maybe 150 to 250 generations. In evolutionary terms, that's not change. That's a transformation. But here's what makes this story even more fascinating. We know this happened because we can compare the genomes of ancient Europeans from different time periods. Thanks to improvements in ancient DNA extraction, Researchers have sequenced DNA from European skeletons ranging from 40,000 years ago to just a few centuries ago. And what they found was stunning. European hunter-gatherers, the people who lived in Europe before agriculture arrived, were dark-skinned. Not African dark necessarily, but significantly darker than modern Europeans. A famous example is Cheddar Man, a hunter-gatherer who lived in Britain about 10,000 years ago. Genetic analysis of his remarkably well-preserved remains shows he had dark skin, dark hair, and blue eyes. That combination looks unusual to us now, but it was probably common among pre-agricultural Europeans. These people had been living in Europe for thousands of years. Some of their ancestors had been there since the initial human migrations 40,000 years ago. They'd had plenty of time to evolve lighter skin if there was strong selective pressure for it. But they hadn't, because they didn't need to. Their fish-rich diets provided adequate vitamin D. Then farming arrived, brought by migrating populations from the Middle East. These early farmers were already somewhat lighter skinned than Africans, having lived in the Middle East for thousands of years. But they weren't as light as modern Europeans either. The really dramatic skin lightening happened after they reached northern Europe, and their vitamin D-rich foods disappeared from their diets. The genetic evidence shows that modern Europeans are a mixture of three ancestral populations: the original dark-skinned hunter-gatherers, the early farmers from the Middle East, and later Bronze Age migrants from the steppes. But the light skin genes swept through all three groups once they were living on grain-based diets in northern latitudes. It didn't matter what your ancestral population was. If you were farming in Scandinavia, your descendants needed light skin to survive. This created a kind of evolutionary feedback loop. Lighter skin meant healthier children. Healthier children meant larger families. Larger families meant agricultural villages could grow and expand. Successful farming communities could support more people, which meant more opportunities for light skin genes to spread through reproduction and intermarriage. Within just a few thousand years, the genetic landscape of Europe had been completely transformed. The same thing was happening in northern Asia, though through different genetic pathways. Agricultural populations in China, Korea, and Japan developed their own light skin variants, mutations in different genes that achieve similar results. The speed of this change tells us something profound about human evolution. When selective pressure is strong enough, when survival is literally on the line, populations can change with stunning rapidity. The mutations were already there, rare variants floating around in the population. Agriculture didn't create them. It just made them desperately necessary. And the people living through this transformation had no idea what was happening. They didn't understand genetics or vitamin D or natural selection. They just knew that some families seemed healthier than others, that some women's children survived while others didn't, that over generations people were gradually, mysteriously becoming paler. But they could see the results. Within a few thousand years, the northern populations had shifted from predominantly dark to predominantly light. The mutation that had been slowly spreading through hunters became a survival necessity for farmers. And agriculture kept spreading, carrying light skin genes further north and east with each generation of wheat and barley farmers pushing into new territories. This is why skin colour changed so much faster than we'd expect from sun exposure alone. It wasn't just about adapting to less sunlight, it was about adapting to less sunlight while eating a diet that contained almost no vitamin D. Agriculture didn't just change where humans lived, it changed what humans ate, and that dietary change created selective pressures more intense than anything climate alone could produce. The people who survived were the ones whose genes allowed them to synthesize vitamin D from the weak northern sun. The ones who could feed their children on grain and still build strong bones. The ones who could farm in forests and survive. They became us. pale-skinned farmers spreading across the north, transforming the genetic landscape of entire continents in just a few thousand years, all because someone decided that planting seeds was easier than hunting deer. Here's where the story gets really interesting. You might think that pale skin evolved once, that there's a single genetic change that turns some humans from dark to light. But you'd be wrong. Evolution doesn't work that neatly, and human migration patterns were far more complex than a simple linear progression. The truth is, pale skin evolved multiple times, in different places, through completely different genetic pathways. This is what biologists call convergent evolution, the same solution arising independently in response to the same problem, like how wings evolved separately in birds, bats, and insects. Similar outcome, completely different mechanisms. The same environmental pressure, low UV radiation, was selecting for lighter skin across multiple human populations. But the genetic mutations that created that lighter skin were different in almost every case. Let's start with the population you probably think of first, the Europeans. When modern humans first arrived in Europe around 45,000 years ago, they encountered a landscape unlike anything their ancestors had ever experienced. Long winters with barely any sunlight, short summers where the sun hung low in the sky even at noon, cloud cover that could last for weeks. And remember, these weren't just any humans. These were people whose ancestors had been perfecting dark skin in Africa for hundreds of thousands of years. They carried multiple genes that produced high levels of melanin, genes that had kept their ancestors safe from UV damage for millennia. But now those genes were killing them. Not quickly, not obviously, but generation by generation, women who couldn't produce enough vitamin D struggled to give birth. Children whose bones didn't mineralize properly died in infancy or grew into adults too weak to hunt effectively. The selection pressure was intense and immediate. Within a few thousand years, mutations that reduced melanin production began spreading through European populations. The primary mutation was in a gene called SLC24A5. This gene controls an ion channel in melanocytes, the cells that produce melanin. The ancestral version of this gene, the one that all humans carried when they left Africa, produces high melanin levels. But a single base pair change, just one letter in the genetic code altered, reduced melanin production dramatically. People carrying 2 copies of this mutated gene, one from each parent, had significantly lighter skin than their ancestors, and crucially, they produced enough vitamin D to survive northern winters. This mutation arose somewhere in the Middle East or southern Europe around 20,000 to 30,000 years ago. We're not exactly sure where or when, because genetic dating has margins of error. But we know it spread explosively. Within 10,000 years, nearly every person in Europe carried at least 1 copy. Within 20,000 years, nearly everyone carried 2. But here's what's fascinating. That same mutation, SLC24A5, is almost completely absent in East Asian populations. The people who migrated into China, Korea, Japan, and Southeast Asia faced the same vitamin D crisis as Europeans. They moved into northern latitudes with low UV radiation. Their dark-skinned ancestors struggled with the same health problems, but they solved the problem differently. East Asian populations developed pale skin through mutations in completely different genes. The primary ones are EDAR and OCA2, along with several others that we're still identifying. These genes affect melanin production through different cellular pathways than SLC24A5. They're like solving the same math problem using different equations. You get to the same answer, but you took a different route. EDAR is particularly interesting because it doesn't just affect skin color. It also influences hair thickness, tooth shape, and sweat gland density. This suggests that the mutation that lightened East Asian skin might have originally been selected for something else entirely. Maybe better cold weather adaptation through thicker hair and different sweat responses. The skin lightening might have been a side effect that turned out to be advantageous for vitamin D production. The genetic evidence shows this mutation arising in East Asia around 20,000 to 30,000 years ago, roughly the same time frame as the European mutations, but completely independently. Two populations separated by thousands of miles, both evolving paler skin through different genetic mechanisms in response to the same environmental pressure. But evolution doesn't follow simple rules, and human skin color doesn't fall into neat categories. Some populations thoroughly disprove the simple equation of northern latitude equals pale skin. Consider the Inuit peoples of the Arctic. They live at some of the highest latitudes on Earth. Parts of Greenland, northern Canada, and Alaska barely see the sun for months during winter. By all logic, they should have evolved the palest skin of any human population, but they didn't. Traditional Inuit populations maintained relatively dark skin despite living in one of the lowest UV environments on the planet. For decades, this puzzled researchers. It seemed to violate everything we knew about skin color evolution. Then geneticists figured out the answer. It wasn't written in their skin. It was written in their diet. The Inuit ate almost exclusively animal products. Seal meat, whale blubber, fish, caribou, and these foods, particularly marine mammals, are extraordinarily rich in vitamin D. A diet heavy in seal and whale provides more vitamin D than most humans could ever synthesize through sun exposure. The Inuit didn't need pale skin because they were getting vitamin D through their food. The selection pressure that drove skin lightening in European and East Asian populations simply wasn't present. They could maintain darker skin, which might have actually provided advantages in their environment. Better protection against UV radiation reflecting off snow and ice. Reduced risk of frostbite since melanin helps regulate heat retention in skin. Without the life or death pressure to produce vitamin D through skin synthesis, there was no evolutionary reason to develop pale skin. They solved the northern vitamin D problem through culture and diet rather than through genetic adaptation. This tells us something profound about human evolution. Biology and culture aren't separate. They interact constantly. The Inuit created a cultural solution, a specialized diet, that removed a biological selection pressure. Other populations that couldn't or didn't develop such diets had to evolve biological solutions instead. Now let's zoom out and look at the global pattern. If you map human skin color across the world, a clear gradient emerges. At the equator, where UV radiation is strongest year-round, populations maintain the darkest skin. This includes people in sub-Saharan Africa, but also indigenous populations in New Guinea, Australia, and parts of South India. These populations never left high UV environments, so they never faced selection pressure to lighten their skin. They retained the ancestral human trait, dark skin packed with melanin, perfectly adapted to intense sunlight. As you move away from the equator, skin tones gradually lighten. This gradient isn't perfect. History, migration, and intermixing have complicated the picture. But the overall pattern holds across continents. In the Middle East and Mediterranean regions, populations developed intermediate skin tones. They received enough UV to benefit from some melanin protection, but not so much that dark skin was essential. Populations in these regions carry mixed genetic signatures. Some genes for light skin from European lineages, some genes for darker skin from African lineages. The result is the olive and tan complexions characteristic of Mediterranean, Middle Eastern and North African populations. South Asia shows a similar pattern, but with even more complexity. Northern Indian populations tend to be lighter skinned than southern populations. This follows the latitude gradient. but it's also influenced by thousands of years of migration and mixing, waves of people moving in from Central Asia, Iran, and other regions, intermarrying with indigenous populations, creating genetic mosaics. Some individuals carry light-skin genes from both European and East Asian lineages, plus dark-skin genes from ancestral populations. The result is one of the most diverse ranges of skin tones anywhere in the world, all within a single geographic region. Central Asia presents another fascinating case. Populations there show evidence of genetic mixing between European, East Asian, and Middle Eastern lineages. They carry SLC24A5 mutations from the West, EDR mutations from the East, and various intermediate genes from populations that never fully lightened. This mixing created populations with skin tones that don't fit neatly into simple categories, not quite as pale as Northern Europeans, not as light as East Asians, but distinct from both. The Americas add yet another layer of complexity. When humans first crossed into the Americas around 15,000 to 20,000 years ago, they carried East Asian genetic signatures. They had already evolved lighter skin through the EDAR and related mutations. But then something interesting happened. As they spread through the Americas, they encountered a huge range of environments, from Arctic tundra to tropical rainforests, from high-altitude mountains to coastal lowlands. Different selection pressures in different environments began pushing skin colour in different directions. Populations that remained in northern regions maintained relatively light skin. Those who moved into equatorial regions like the Amazon began evolving darker skin again. They were reinventing protection against high UV radiation. By the time Europeans arrived in the Americas, indigenous populations displayed a wide range of skin tones. Inuit peoples in the Arctic maintained moderate pigmentation. Populations in temperate North America had light to moderate skin. Groups in Mexico and Central America showed more pigmentation. And Amazonian peoples had developed quite dark skin, approaching African levels in some cases. All of this happened in less than 20,000 years. A blink of an eye in evolutionary terms, but fast enough to create visible differences in response to local environmental pressures. Then came the modern era, the age of exploration, colonization, and mass migration. People from every corner of the world began moving, mixing, having children together. European genes flowed into the Americas, Africa, and Asia. African genes spread to the Americas and Europe. Asian genes reached everywhere. This mixing created populations with unprecedented genetic diversity. Modern populations in the Caribbean, Brazil, Mexico, and the southern United States carry genetic signatures from 3 or more continents: African, European, and indigenous American, sometimes with Asian contributions as well. The resulting range of skin tones is extraordinary. Within a single family, siblings can have dramatically different colouring depending on which combination of genes they inherited. This mixing is still accelerating. Every generation sees more genetic exchange between populations that evolve separately for tens of thousands of years. We're creating a global human population with unprecedented genetic diversity. But here's what's beautiful about all this complexity. Despite the different paths, the different mutations, the different timescales, we're all connected. Every human alive today is descended from those African ancestors who first developed dark skin as protection against the sun. The pale skin, the intermediate tones, the infinite variations we see today, they're all modifications of that ancestral trait. Evolution didn't create separate types of humans. It created a spectrum, a gradient, a beautiful range of variation, all based on the same fundamental biology. Your skin colour, whatever it is, tells a story about where your ancestors lived, what challenges they faced, how they adapted to survive. But it's not a story about essential differences, it's a story about superficial variations on a single theme. We're all the same species, all carrying the same basic genetic toolkit, just with slightly different settings adjusted to match the sunlight where our ancestors happen to live. And now, as we drift deeper into sleep, consider this. The next time you see someone whose skin looks different from yours, remember you're looking at a different solution to the same problem, a different path that led to the same destination. We're all descendants of the same African ancestors, all products of the same evolutionary processes, all human. By the time your ancestors had pushed deep into the north, something else was quietly happening, written not just in their skin but in their hair, their eyes, even the shape of their bodies. You can picture them now, huddled around a fire under a grey Ice Age sky. The world is pale and muted, snow on the ground, low winter sun, weeks where the daylight feels more like twilight. In a place like this, the sun isn't just weaker, it's rare, and that changes everything. Lighter skin was one solution to that problem. You already know the story. Less pigment lets in more UV. More UV means more vitamin D. More vitamin D means stronger bones, healthier pregnancies, fewer children born with fragile skeletons that couldn't survive. But skin wasn't the only thing changing. In Europe, another set of traits began to spread, like branches growing out from the same evolutionary trunk. Not exactly the same process, not exactly the same genes, but responding to the same harsh, low-light world. Let's start with the eyes. If you could have walked into Ice Age Europe 50,000 years ago and looked closely at the people you met, most of them probably would still have had dark eyes, brown like the soil after rain, brown like their African ancestors. But slowly, in some families, a tiny change appeared. One letter in their DNA at a region called OCA2HER2 shifted. It didn't break anything. It just dialed down the amount of brown pigment in the iris. Take away enough pigment and the eye stops looking dark. Instead, it starts scattering light the way the sky does. That scattered light looks blue. That's all blue eyes really are. Not blue pigment, just a trick of physics. Light bouncing around inside an iris that doesn't have much brown in it. At first, this mutation may have appeared in one person. One child, born with eyes that looked like the winter sky. Maybe their parents thought it was strange. Maybe they thought it was beautiful. Either way, if that child survived and had children of their own, the mutation had a chance to move forward. Did blue eyes evolve for a reason? Or were they just a side effect of something else? We don't know for sure, and that's where the story gets interesting. There are clues, but no final verdict. Some scientists think that as skin became lighter to help with vitamin D, the genes that controlled pigment in other parts of the body, like the eyes, got pulled along for the ride. A sort of genetic hitchhiking. The mutation in the OCA2HER2 region might have spread because it happened to sit near other useful changes being selected for in the harsh northern light. Others suggest that once blue eyes appeared, they might have been favoured socially. In small Ice Age bands where everyone knew everyone, something unusual could stand out. Maybe a rare eye colour became a marker of identity, a trait that made a face easy to remember, a person more interesting as a partner. Sexual selection, layered on top of natural selection. The truth is it could have been both. A mutation that drifted in on the tide of skin lightening and then stayed because, for whatever cultural or psychological reason, people who had ended up leaving more children. And it wasn't just blue. As more pigment-related genes drifted and mutated in low UV environments, you start getting a whole spectrum of eye colours. Green, hazel, grey, eyes that change in different light, eyes that seem to hold the colours of the landscape itself. Forest, sea, storm clouds. All of this was happening while those same populations were dealing with another problem, staying warm. In the tropics, Long limbs and lean frames help shed heat, but in the north, heat is something you hoard. Here, a different package of traits begins to show up in skeletal remains. Bodies get a little stockier, more compact, arms and legs slightly shorter relative to the torso, more like a thermos than a radiator. This isn't random. It's what biologists call Bergmann's and Allen's rules. In colder climates, animals tend to be bulkier with shorter extremities to reduce the surface area through which they lose heat. Your Ice Age ancestors didn't read those rules, they embodied them. Even their faces told a cold climate story, the nose especially. In bitter, dry air, breathing is dangerous. Too cold, too fast, and the delicate tissues of the lungs can be damaged. So in populations living in cold, dry environments, selection seems to have favoured narrower, more projecting noses. Longer internal airways that could warm and humidify the air before it reached the lungs. In warmer, wetter climates, this isn't as crucial. Wider noses are fine, even useful for moving more air quickly. But in the north, the nose became a built-in climate control system, a tiny biological furnace and humidifier sitting right in the middle of the face. So now, around that Ice Age fire, you can begin to see the pattern. Lighter skin, filtering scarce sunlight, eyes that sometimes gleam blue or green, bodies that are slightly shorter, stockier, noses tuned to cold, dry air. These traits didn't always appear together. A stocky build could exist with dark eyes, a light eye colour with a broader nose. Evolution isn't a tidy designer, it's a tinkerer. Different genes, on different chromosomes changing at different times, under overlapping but not identical pressures. But because these traits all made sense in similar environments, they often travelled through the same populations, not as a single northern race, but as a loose bundle of adaptations, what you might call a northern package. Hair joined in too. In high latitude Europe and parts of Western Eurasia, new hair colours began to appear. Just as with eyes, the changes were about pigment, this time melanin in the hair shaft. A mutation here, in a gene like MC1R, and the balance between two types of melanin shifts. Less of the very dark eumelanin, more of the reddish pheomelanin, and suddenly someone is born with hair the colour of embers rather than coal, red hair. Change the balance another way, lessen pigment overall, and hair becomes honey-coloured, then truly blonde. Fine, pale hair catching the low sun like straw, like the last light before winter dusk. These colours probably began as rare accidents, just like blue eyes. Do they have a clear survival advantage? Maybe, maybe not. In places with very weak sunlight, less pigment in the hair and skin might have slightly improved vitamin D production. But many researchers think the story here leans more towards sexual selection, unusual traits standing out in small populations, where every face is familiar and difference can become desirable. Imagine a world with no artificial lights, no screens, no neon signs. The brightest, most colourful thing you see all winter might be another human being. In that world, hair the colour of autumn leaves, or eyes the colour of ice on a deep lake, might have felt almost magical. And once a trait becomes desirable, even for purely social reasons, evolution pays attention. People who carry those traits might have more mates, more surviving children, and slowly, over thousands of years, those once rare mutations become common in certain regions. But it's important to remember, none of this was inevitable. In East Asia, for example, skin also lightened under northern skies, but the specific genetic pathways were different. Different mutations, same overall outcome, a new solution to the same problem. Eye colour there mostly stayed dark, hair stayed black in most populations. The northern package looked different depending on which branch of humanity you were looking at, and which particular mutations happen to arise and spread. That's the deeper pattern behind all of this. You're not looking at one simple story where north equals pale, south equals dark. You're looking at dozens of overlapping stories, climate sculpting bodies, diet sculpting skin, culture and attraction sculpting hair and eyes, different human groups in different places, solving the same challenges with different genetic tools. Every trait we've talked about, eye colour, hair colour, body shape, nose structure, is controlled by many genes. Each gene can have multiple versions. Each version can be nudged by selection, reshuffled by sexual choices, or simply drift through a small population by chance. So when you look around the modern world and see a red-haired person from Ireland, a blonde-haired child from Sweden, a brown-eyed farmer from China, a dark-skinned herder from Sudan, what you're really seeing is one species that has tried out hundreds of slightly different solutions to the same basic problems. How do we stay warm? How do we protect ourselves from the sun? How do we get the vitamins we need? How do we choose each other? Underneath it all, the same bottlenecked, crisis-tested human brain. The same 46 chromosomes, including that fused pair inherited from a tiny population that almost vanished 800,000 years ago. The same capacity for language, for cooperation, for storytelling. But on the surface, infinite variation. And here's the quiet, sleep-friendly secret in all of this. These visible differences are recent, very recent. Most of the traits we think of when we picture Northern or European or cold adapted likely reached high frequencies only in the last 10,000 or so years, some even more recently. For the vast majority of our species' history, we all looked more alike than we do now. The Northern package is just one of many late experiments, an add-on, a patch, a local update applied to a very old human operating system. Lighter skin in the north, darker skin in the tropics, blue eyes near the Baltic, green eyes around the Caspian, red hair pockets in Western Europe, stocky frames in Siberia, long limbs in East Africa, each one a quiet response to wind, sun, cold, food, and the mysterious ways humans choose partners. Put it all together, and the message is simple and strangely calming. Humans are adaptable, ridiculously adaptable. Our bodies are flexible stories, rewritten by climate and culture and time. Your own face, your own skin, your own eyes and hair are a chapter in that story. A trace of ice and sun, hunger and abundance, danger and desire, carried forward through thousands of sleeping ancestors all the way to you. And as your breathing slows and your own eyes grow heavy, you can imagine those ancestors, dark-eyed in Africa, blue-eyed in Europe, brown-eyed in Asia, blinking up at the same sky, trying to survive one more winter, one more dry season, one more storm. Their adaptations kept them alive. Their survival made you possible. Fast forward to almost now. The ice ages have come and gone. Agriculture has risen and spread. Cities glow at night where mammoths once grazed. Planes cross oceans in hours, and the careful matching between skin colour and sunlight intensity that took tens of thousands of years to evolve starts getting scrambled in just a few generations. For most of our history, people tended to stay put. Your ancestors might move a few valleys over, maybe follow herds a few hundred miles, but the sunlight where they lived, the UV radiation pouring down on their skin, stayed broadly the same for thousands of years. Evolution had time to tune their skin pigmentation to those local conditions. Dark where the sun was brutal, light where the sun was weak. Then, very recently, everything changed. Ships started crossing oceans, empires expanded, trade routes turned into migration routes. People from intensely sunny homelands found themselves living under grey northern skies. People whose ancestors had evolved in misty, low UV climates moved to fierce tropical coasts. In just a few centuries, the slow dance between climate and skin colour was thrown into chaos. Imagine a map of the world at night glowing with city lights. Now imagine another map layered on top of it, showing where your skin expects to be, based on your ancestry. If evolution had its way, dark skin would cluster around the equator, fading gradually as you move toward the poles. But the real map now is different. Dark-skinned families in Stockholm, pale-skinned families in Brisbane, mixed heritage kids everywhere, their genes carrying UV histories from half a planet away. Our bodies are still running software written by ancient sunlight. But we've changed the hardware, our environment, almost overnight. Take Australia, especially places like Queensland. It sits under some of the strongest UV radiation on Earth. For tens of thousands of years, the Aboriginal peoples of Australia evolved deep, protective skin pigmentation that worked beautifully with that extreme sun. Then, in the last few centuries, large numbers of very light-skinned Europeans arrived. Skins that had been shaped for the cloudier skies of Britain, Ireland, and Northern Europe found themselves under a blazing, unforgiving sun their melanocytes were never built to handle. The result? A skin cancer experiment, running in real time. In high UV regions like Australia, New Zealand, and parts of South Africa, fair-skinned populations have some of the highest rates of skin cancer ever recorded. Basal cell carcinoma, squamous cell carcinoma, melanoma, the most dangerous kind. These are not evolution's mistakes. They're what happens when we move faster than evolution can follow. Your light skin was never designed to make you sick. It was selected because in dark, low UV environments, it let your body produce enough vitamin D to build strong bones, healthy immune systems, and surviving children. But move that same skin suddenly to a harsh tropical sun, and the trade-off flips. The advantage, fast vitamin D production, no longer matters because there's vitamin D everywhere in that sunlight. Instead, the vulnerability becomes fatal. UV rays slice through unprotected cells, damaging DNA. Most of the time, your body repairs it. Sometimes the repairs are imperfect. A cell goes rogue. A tumor begins. Now flip the situation. Think of a family whose ancestors evolved under the burning equatorial sun. Deep melanin layers, powerful natural sunscreen. For hundreds of generations, that skin tone was perfect. It blocked the UV that would have destroyed folate in the bloodstream while still letting through enough to make vitamin D in a place where sunlight was abundant year-round. Then, within a few decades, maybe just a single lifetime, that family moves north. Not just a little north, far north, London, Oslo, Toronto, long winters, short low-angle suns, cloudy skies. That same protective melanin now becomes a barrier. It's still great at blocking UV, but now UV is precious. Your skin needs every photon it can catch just to produce enough vitamin D. Days are short. The sun is weak. You go from an environment where vitamin D was effortless to one where it becomes a fragile resource. Vitamin D deficiency doesn't announce itself with flashing lights. It creeps. Bones ache. Children may develop rickets, soft bones that bend and deform. Adults become more prone to fractures, to immune problems, maybe to subtle mood changes as the seasons turn dark. Ancient evolutionary logic, protect folate at all costs in a brutal sun, is now colliding with a modern life lived in a cold, dim world, often indoors, under roofs and fluorescent lights. So you have two mirror image problems. Light-skinned people transplanted to high UV environments, overexposed. Dark-skinned people transplanted to low UV environments, underexposed. Both situations are evolution out of sync with geography. But humans have a new trick. a trick older species never had. We hack evolution. We invent sunscreen, hats, long-sleeved shirts woven from fibres no Pleistocene hunter could dream of. We create vitamin D pills, little compressed tablets of sunlight in a bottle. We fortify milk, cereal, infant formula, even some plant-based milks, with extra vitamin D. Fake summer dissolved into everyday food. We build UV lamps for people whose winters are too long. We study our own biology and quietly reroute the ancient pathways that used to be controlled only by climate and selection. Your ancestors evolved to match their skin to their sky. You can now change the rules in a single afternoon trip to the pharmacy. The consequences are profound. For the first time in our history, skin colour doesn't fully determine where we can live safely. A deeply pigmented person can be perfectly healthy in northern Canada, as long as diet and supplements cover the vitamin D gap. A very light-skinned person can live for decades under tropical sun if they shade, cover and screen their skin from excess UV. Technology has turned evolution's slow compromises into adjustable settings. But evolution hasn't stopped. It never stops. Every generation, new mutations appear. Some help, some hurt, most do nothing noticeable at all. And the environments we've created, cities, diets, medicine, indoor lifestyles, are all new arenas for natural selection to work in. Is skin colour still evolving? Almost certainly, but not in the simple, straight-line way it once did. In places where many ancestries mix, big modern cities, global hubs, you now get children whose genes come from multiple UV histories at once. A kid in London whose grandparents came from Lagos and Warsaw, and Mumbai and Shanghai. There is no single correct sunlight for that genetic mix. Instead, evolution might start tuning for something new, not just raw UV levels, but how those genes interact with diet, healthcare, time spent outdoors, cultural habits. Maybe, in a few thousand years, if humans stay put in their new homes and stop relying as much on supplements and sunscreen, you'd see subtle shifts again. Slightly more melanin where the sun is strong, slightly less where it's weak. But with global travel, intermarriage across continents, and powerful technology, natural selection on skin colour is now competing with cultural selection, with conscious choice. Parents move for jobs, for safety, for love, not for UV levels. Doctors prescribe vitamin D drops for infants and sunscreen for toddlers on the beach. Public health campaigns nudge behaviours in ways evolution never anticipated. The old rules, dark near the equator, light near the poles, still describe the deep past. They no longer describe the future as cleanly. And this is where understanding the story really matters. When you know that skin colour is, at its core, an ancient negotiation between sunlight, vitamins, and survival. The way you see it changes. It stops looking like a rigid category, a fixed label pinned to people. It starts looking like what it really is, an evolving, adaptable, exquisitely practical solution to local problems. Dark skin is not better or worse than light skin. It's a high melanin strategy that worked brilliantly in high UV environments. Light skin is not better or worse either. It's a low melanin strategy that made life possible in places where the sun barely shows its face in winter. In a world without ships, planes, or electric lights, each tone was a masterpiece of adaptation. The modern world just shuffled the deck. Now, neighbours on the same street may carry skin tones that remember very different suns. Your co-worker's melanin might be tuned for equatorial intensity, yours for foggy northern coasts, someone else's for high mountain plateaus or temperate forests. Standing together at a bus stop under the same sky, you are all carrying different evolutionary memories of light. Technology lets us smooth over the mismatches, but it can't erase the story. And knowing that story changes how we think about diversity. When you look at your own skin in the mirror, you're not just seeing a colour, you're seeing a map, a record of migrations your ancestors made, climates they endured, nutritional crises they solved, disease pressures they survived. Each freckle, each shade, is an echo of old sunlight falling on old landscapes. When you look at someone else's skin, you're seeing a different map, a different set of migrations and solutions, not a hierarchy, a library, a collection of answers to the question, how can a human body live here? In the past, those answers were largely locked to place, dark near the equator, light near the poles. Now, in airports and subway cars and university classrooms, all those answers mingle. The Amazon and the Arctic Circle ride the same train. The Sahel and Scandinavia sit next to each other in school, and instead of letting those visible differences divide us, we can treat them as clues, evidence that we are a species built to adapt, to survive, to spread into every corner of the planet. Evidence that the boundaries we draw, us and them, light and dark, are shallow compared to the deep, shared history written beneath every shade of human skin. As you lie there, maybe in a darkened room lit only by a small screen, your own skin is quietly doing its work. Melanin molecules absorbing stray photons, vitamin D pathways humming along, supported by food or supplements or last week's time in the sun. Layers of adaptation, ancient and modern, working together. The old world tuned our bodies to specific skies. The modern world lets us carry those bodies anywhere. Adaptation met migration, evolution met technology. And out of that meeting came a world where the colour of your skin still tells a story about where you come from, but no longer dictates where you can go. So after all of this, after bottlenecks and migrations, ice ages and sunshine, genes switching on and off like tiny molecular light dimmers, what does skin colour actually mean? Biologically, it means one thing. It tells you how much ultraviolet radiation your ancestors' skin had to manage. That's it. Not how smart they were, not how kind or brave or creative, just how much sun their bodies has to solve a very specific problem for. If your ancestors lived for tens of thousands of years under brutal equatorial sunlight, they needed heavy-duty protection. Dark skin loaded with melanin acted like natural sunscreen. It shielded folate in the blood, protected DNA, reduced the risk of skin cancer, and kept developing embryos safe. If your ancestors wandered into places where the sun barely dragged itself above the horizon in winter, they faced a different danger. Not too much UV, but too little. They needed to squeeze every last photon of sunlight into vitamin D. Their lighter skin was like opening the blinds wider. Less melanin meant more UV getting in, faster vitamin D production, stronger bones, healthier pregnancies. So when you look at someone's skin, what you're really seeing is a climate report, a UV history, a record of how much sunlight their lineage has negotiated with over the last 40,000, maybe 50,000 years. In evolutionary terms, that's yesterday. For most of our existence, every human walking the earth had dark skin. Deep brown, rich in melanin, tuned for the high UV world of Africa where our story began. The first people who looked anything like white Europeans. They're a recent twist, the result of a few mutations that spread rapidly when our ancestors started farming in cloudy northern skies. Ancient hunter-gatherers living in Ice Age Europe. Many of them likely had dark skin and light eyes, or some other combination that doesn't fit our modern boxes. The sharp colour boundaries we imagine today didn't exist. They're new. They're fragile. They're still changing. But our brains love boxes. They love categories. So we invented one. Race. We told ourselves that skin colour, hair texture, facial features all lined up neatly into a handful of discrete types, We gave those types names. We attached stories to them. Stories about ability, about worth, about who belonged and who didn't. The trouble is, biology didn't cooperate. When geneticists look at humans, they don't see crisp lines. They see gradients, blends, smooth transitions across continents, like colours bleeding into each other on a watercolour map. Walk from the equator to the Arctic, step by step, village by village, and what you see isn't a set of sudden jumps from race to race. You see a slow shift in skin tone, facial features, body proportions, hair types, all adjusting to local climates, diets, and histories. A continuous fabric, not a quilt of separate pieces. There is variation, of course. Real, visible, measurable variation. But when you zoom in at the level of DNA, that variation behaves very differently from the way our social labels suggest. Two people from the same race can be more genetically different from each other than either of them is from someone in a different race. Most of the genetic diversity in our species, around 85 or 90% of it, exists within local populations, not between them. What we call race captures a thin slice of surface traits, mostly tied to climate adaptation, and then inflates their meaning until they feel like destiny. Underneath all those surface differences, the numbers tell a very quiet, very simple story. All humans share about 99.9% of their DNA. That tiny 0.1% accounts for everything we can see. Tall or short, curly hair or straight, dark skin or pale, green eyes or brown. All the visible diversity of 8 billion people, squeezed into a fraction of a fraction. And even inside that 0.1%, almost none of it sorts neatly into our racial categories. Your skin colour might line up with one group on a census form. Your lactose tolerance might line up with another. Your immune genes, your smell receptors, your ability to handle high altitude or digest certain plants. Those might trace to ancestors scattered across continents you've never seen. Your body is a mosaic assembled from thousands of ancient experiments, hundreds of migrations, dozens of small survival stories. None of that complexity fits inside a simple label. Race, as we usually talk about it, is not a biological fact. It's a social invention built on top of a few real biological trends. There are patterns. People whose ancestors lived in West Africa tend to cluster genetically more closely with each other than with people from East Asia. People from Northern Europe tend to share more recent ancestors with each other than with people from the Pacific Islands. But if you try to draw hard boundaries, evolution laughs at you. Where exactly does Europe end and Asia begin in DNA? There is no single answer. The borders wobble, blur, dissolve under scrutiny. Every line you draw is part science, part politics, part history. The truth is gentler and stranger. We are one continuous family that never really stopped moving. Those early dark-skinned humans who stepped out of Africa around 60,000 years ago, they are the ancestors of everyone currently called white, black, Asian, Latino, Pacific Islander, and every other label we've created. There is no branch of humanity that did not pass through that African bottleneck. There is no pure group that stands apart. We are all remix versions of the same ancient survival track. The genes that made some of us pale are teenagers in evolutionary time. Skin-lightening mutations common in Europe are maybe 6,000 to 10,000 years old. Some in East Asia are different mutations altogether, arriving independently. Separate solutions to the same dim sun problem. Think about that for a moment. A person with very light skin in Sweden and a person with very light skin in northern China became pale for different genetic reasons at different times in different places. Yet if you put them side by side, a casual observer might say, same race. Meanwhile, two people with very dark skin from distant parts of the tropics might be more genetically different from each other then either is from one of those pale-skinned strangers. Our social categories are trying to map a three-dimensional, swirling, overlapping storm of ancestry onto a flat little chart. No wonder they keep tearing at the edges. But instead of feeling lost in that complexity, you can let it calm you. Because once you understand what skin colour really is, a local tweak for UV radiation, nothing more, you're free to see something deeper. You can see that the full range of human colour, from the deepest ebony to the palest ivory, is not a hierarchy. It's a weather report, a record of sunlight and seasons, an atlas of where your ancestors stood under the sky and how their bodies learned to make peace with the light. You can see that the curve of a nose, the shape of an eye, the thickness of a lip are not badges of superiority or inferiority. They're quiet archives of climate, diet, and chance. Adaptive footnotes in a story that has always been about staying alive just long enough to have children who could do the same. When you look around at humanity, the freckles and albinism, the golden brown, the red undertones, the olive shades, the near black that swallows light and throws it back as a soft sheen, you're really looking at evidence. Evidence that our species is astonishingly flexible, that we've walked through deserts and tundras, rainforests and high plateaus, and found a way to belong in each. Our diversity isn't a problem to be explained away. It's a map of where we've been. Each shade of skin is a postcard from a different latitude. Each facial feature is a rumour from a different climate. Each one whispers, "Someone like you survived here." And beneath all those variations, the similarities are overwhelming. The same 206 bones, the same 600 plus muscles, the same neural wiring that lights up when we hear a baby cry, or a loved one laugh, or a story that feels like it belongs to us. The same basic brain that learned to tame fire, to nap stone, to plant seeds, to build cities, to send robots to other planets and lullabies to other hearts. No matter how you look, your ancestors lived the same essential drama as everyone else's. They worried about food, they mourned their dead, they told stories around flames and under stars, they taught their children where the water was, where the danger was, where the hope was. Your skin is not a wall. It's a thin, living border between your inner ocean of cells and the wider world. It's your first line of defense, your solar panel, your sensory blanket. And like everyone else's, it's built out of the same proteins, the same pigments, the same ancient instructions, copied and recopied through a chain of bodies stretching back nearly 1,000,000 years. If you trace your lineage far enough, past nations, past empires, past languages, past even the first whisper of white or black as ideas, you end up in the same place as everyone else, on African soil, under a hot sun, inside the skin of a small, dark-skinned population that had almost disappeared but didn't. Those people are your people. Their struggle is written in your cells. Their near extinction is the reason you exist at all, and everyone you've ever met carries that same inheritance. So as you lie here listening, letting the details blur, you can let your mind drift over the planet, over cities glowing softly in the dark, over villages tucked into valleys, over ships at sea, and research stations in ice, and tiny camps in deserts under a cold moon. Everywhere you look, people are sleeping, or whispering, or dreaming. Brown skin, black skin, pale skin, golden skin, all of it doing the same quiet work, repairing, rebuilding, preparing for another day under whatever sky they were born beneath. All of them cousins, not metaphorically, literally. The deep meaning of skin colour is not that we are different species or different kinds of human. It's that we are one species so adaptable, so inventive, so stubbornly alive, that we've learned to turn sunlight itself into a sculpture of our appearance, without ever changing what matters underneath. Bones, blood, stories, fear and courage, loss and love. These are the things that define us, and they do not care about melanin. So when you think about skin color now, you can think of it as a soft overlay, a filter the Earth placed on us in different places for different reasons. Beautiful, yes. Meaningful in a narrow biological sense, yes. But not a measure of worth, not a boundary on who you're connected to. In the end, all those colours flow back into the same river of ancestry, the same shared origin, the same fragile, miraculous survival. And as you drift towards sleep, you can rest in that knowledge. You are part of one immense, intertwined human story. Your skin is just your chapter's cover art. The book beneath is the same one everyone else is carrying. So here you are, lying in the dark or in the glow of a small screen, at the very end of a story that started long before there were screens, or cities, or even words. 300,000 years of human history, and all of it is written quietly in your skin. Tonight we've followed that story from its beginning, from small bands of dark-skinned humans under the fierce African sun, to scattered survivors of ancient climate disasters, to explorers stepping cautiously into new latitudes where winters were long, skies were grey, and sunlight was suddenly rare and precious. We watched as bodies changed slowly, generation by generation. Melanin shields that once protected against burning equatorial light began to thin in the north. Mutations that let in a little more UV, made just enough vitamin D, kept a few more babies alive through the hungry seasons. Those tiny differences spread. They became patterns. They became what we now call white skin, or light skin, or olive, or brown, or anything in between. You're carrying that whole journey on the surface of your body right now, the exact shade of your skin. It's a memory, a record of which latitudes your ancestors stood under, how much sun they got, what foods they grew, which winters they survived, which risks they faced again and again until their DNA bent itself around those challenges. Your skin is not a label, it's not a ranking system. It's an evolved solution to a particular set of problems. A quiet, biological love letter from the past saying, we made it, we adapted, we kept going so that you could be here, breathing in this moment. When you look at yourself in the mirror, you're not just seeing light or dark or in between. You're seeing deserts and coastlines, glaciers and grasslands. You're seeing ancestors huddled around fires, tracking the seasons, noticing when the sun came back, adjusting their lives and their bodies to match the sky. And when you look at anyone else, anywhere on Earth, you're looking at another survival story, another path through the same 300,000-year maze. Maybe their people stayed close to the equator and kept that deep protective armor of melanin. Maybe they drifted into northern forests or stormy islands, or high mountain valleys where Denisovan genes still whisper instructions for breathing thin air. However different you seem on the surface, you're both carrying the same ancient bottleneck, the same fused chromosome, the same long, improbable chain of lucky births, one human family, 1,000 different ways of wearing the past. If this journey kept your mind gently busy while your body relaxed, if it helped you drift a little closer to sleep while still feeding that quiet curiosity inside you, you might want to hear more stories like this. Soft, slow history. Big ideas told in a way your nervous system can handle at midnight. If you'd like that, you can tap like on this video. It helps other wandering, sleepless brains find it too. You can subscribe so you don't miss the next slow trip through deep time. And when you're awake and feel like sharing, I'd love to know, where are you listening from tonight? Which part of the planet is cradling you while you fall asleep with all this ancient history in your head? Let me know in the comments when you have the energy. If you want to go one step further, there's also an option to join the channel as a member. That kind of support helps me keep making long, careful videos like this. but it is completely optional. Your presence here, your attention, is already more than enough. For now, you don't have to remember any of the dates or the names. You don't have to hold on to the technical details about vitamin D or melanin or ancient migrations. You can just let it all blur a little, like footsteps in the sand as the tide comes in. Just this one thought is enough to take with you into sleep. Every cell in your body is proof that your ancestors were good enough at living, good enough at adapting, good enough at loving, protecting, and hoping, all the way from the African night sky to wherever you're resting now. Different shades, different stories, one continuous line. As your breathing slows, imagine all those lines weaving together around the globe like faint glowing threads in the dark. Billions of people, billions of journeys, all tracing back to the same small, frightened, determined groups who refuse to give up. You are part of that. You always were. Let your eyes grow heavy. Let the story keep going without you for a while. The sun will rise on the same shared planet tomorrow, painting the same spectrum of human skin with the same light. And you can drift off knowing that, under everything, we are one extended family, still adapting, still learning, still here,